Okay. I sent 2 emails because I knew somebody was going to go bonkers and run in a ditch, you know, because I said something. Okay, I don't know why it isn't. Okay, she can see it. I sent out an email yesterday. The college is wanting teachers to, this is the exact words, to start thinking about alternative methods of teaching. So I guess they're going to move away from the posters a little bit. What do y'all think? And think about e-learning. Basically, that's what y'all call it in District 5, 4, and 3, right? E-learning, right? Well, y'all are already doing it in here. The only thing different is that if something were to happen, like it's not going to happen in South Carolina, and people start running into ditches and cars start catching on fire, then you're welcome. I think the college is thinking about what if, you know, and y'all need to be thinking about that. So let's say that the college says, okay, the Pendleton campus is closed. Why? Because it is more populated, right? So they may close the Pendleton campus and leave the community campuses open. They may not. They may close all the campuses. Either way, you need to decide, because I'm going to keep what? I'm going to keep teaching because I can teach from home and I can teach from here. I can come into work here and teach unless they tell me not to, and then I can teach from home. Either way, I'm still going to be putting videos up, right? So therefore, you can still what? Watch the videos, or you can Skype in.
On secured channel.
Let me see if that's Miss Duziak, because she can't. Okay, oh, okay. We're just going to Skype in at 8:20. Okay. All right. Let me let this Skype. So I need y'all to be, you know, keep your, you know, keep an open mind, and just make sure that if I send you an email, you don't go, I don't know what he's talking about. No, that don't work. Read your freaking emails, Mr. Justice. Okay? Anybody got a question about that? And we are just in the pre-panic stage, okay? And you know in South Carolina, that'll last about a day or two. And then everybody will go into full-fledged panic and run around in circles. Okay, let's say Mr. Justice. Mr. Justice, are you there? Can you see my screen?
It's loading in.
Can you see my screen?
I can, thank you.
Okay, go ahead and mute and jump in if you got questions. So I guess the best word would be watch your emails, and if you see an announcement that says Tri-County Tech will blah 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 blah, if it affects you coming to class, then you're going to get an email from me that says this is what you can do. And basically your choices with me are you can Skype in to wherever I'm teaching from, or you can watch the what? Because the homework and the tests are still what? So as long as I supply you videos, you can still do the what? Work. Now you will have to click on the videos and you will have to watch them for some of you may not. Okay? But the point is that I already have the alternative plan to teach, so you just have to what? Fall in line. If you're not coming to class, and you're going to have to figure out which one you want to do. And you see how I just pulled these two in. That's how I would do y'all. You would just text me. I think there's a handout. Didn't I give y'all a handout that says, you know, how to Skype in? Okay, read it, please. And like these two people did. They just text me, I want to Skype in. I realize that there's 30 people. I know that I've had 15 students on Skype at one time. I don't know if it will hold 30, but there's only one way to find out, you know. And if it doesn't work, then, and it says too full, then you just need to watch the video, because I'm going to record. If I don't record, then I'll pull up a video from last semester, like I've done before with y'all. Okay? Everybody got that? Anybody got any questions on what if? I need to cover that today, because that Tri-County Tech email is going to set everybody, especially the hammies, they're going to go into hysterics. So don't be a hammy. Just be informed and just chill out. Because every election year, have y'all noticed? Every election year, we have a virus from China. You ever noticed that? Google it. But, I don't know. Let's go ahead and pull up the handy dandy 6.1. I want to pull up the outline. If you've got the outline, if you're the one student that printed it out, go ahead and get it out, because I want to show you what we're going to do. I don't know why this, when I pull this up, it does this. I don't know why it puts these funny things in here, but probably the Russians infiltrating my syllabus. If you'll look, I'm going to cut Unit 3 to 4 sections. And there are the 4 sections, so write those down. 6.1, 6.2, 7.1, 7.2. I'm going to make that Unit 3 test. I'm going to make 8, 9, and 10 Unit 4 test. Okay, so we're going to go over 4 sections, and then we're going to have a Unit 3 test. Chapter 8 is not going to be that, 8 and 9, I might get into 10, I don't know, but chances are I will at least hit the first 2 sections. But 8, 9, and 10 kind of belong together, so that's why I don't want to put 8 in Unit 3. So let's start with 6.1. I did start this with the 23 class. I started it with them, so the video I posted yesterday was the start of 6.1. Now, we're going to be dealing with a kind of a cross between probability and statistics. Now, if you remember, back in Unit 1, we talked about a frequency distribution, correct? And the frequency distribution, well, I'll just go back here. A frequency distribution looked kind of like a table. That's not supposed to be there. Whatever. Okay, this is a frequency distribution. You have your class or your category over here, and you have your head count over here. Remember us talking about this? Blondes, brunettes, redheads, 4, 3, 2, right? That was statistics, Unit 1. And then you learned about probabilities. You learned that the probability of an event is equal to 0.32. Now, you merge those two, and then you have what's called, write this down, a probability distribution. And a probability distribution is going to be X and the probability of X. Think of World Series games. Going to 4 games, 5 games, 6 games, 7 games. 0.3, 0.2, 0.4, 0.1. That is what you call a a probability distribution. That's what we're going to be talking about in 6.1 and 6.2. Now, there's two tests for the probability distribution. One, each probability has to be between 0 and what? Hey, come here. Hold on. That's wrong. Has to be between 0 and 1. And all the probabilities has to equal what? 1. So if you have a negative probability, you can't do it. If you have a probability over 1, you can't do it. So make sure you run that test, because on a standardized test, you will have one on there that you can't do, and you'll be trying to do it, and you're going to get it wrong, and you didn't even have to try to do it. All you had to do is look at it. Okay? You're going to see that here in just a minute. Another thing you're going to be talking about, N, P, and X. That's the order that you type it in your calculator. What have I always told you about N? It's always your what? It's always your biggest number. P is going to be your probability, percentage, area, whatever you want to call it. Probability, percentage, area. You'll find out in chapter 8 or 7 that probability, percentage, and area are all the same thing. So N is always your largest number in the problem. And X is what I call the desired. What does that mean? Well, let's say that I flip a coin 50 times. And 0.3 comes up tails. What is the probability if I flip that coin 5 more times that it's going to come up tails? What is N? What's your biggest number? 50. Okay, what is P? 0.3. Then what's the only number left? 5. 5 more times. Got it? So whenever you're dealing with a probability distribution, or in this case a binomial distribution, because you only got 2 choices, heads or what? Tails. That's called a binomial probability distribution, but we'll get to that. Then you type in N, P, and X. And it's going to have N, P, and X. N will be your largest number. P will usually be a decimal or a fraction or a percentage, and you change it into a decimal. And then X will be the only number left, which is usually the smaller number. Does that, everybody understand that? Now, I have no idea whether y'all have seen this or not in high school. I don't know how far y'all go in high school, okay, with the 120. So I have no idea if you've seen, give me an idea, have y'all seen probability distributions before? Okay, have you? You have in probability high school? Anybody else? Okay, so you do get to it, or is it at the very end, or it depends on the teacher, if it's a high school football coach or a real math teacher? What? It depends on the teacher. Okay. All right. So we're going to move on. I'm just giving you a kind of a rundown of what we're going to go over today. So with that being said, there, thank you. We're going to get people, I'm not going all through that. Y'all know what a random variable is, but if you want to write it down, random variables are denoted using letters such as X. A random variable is a numerical measure of the outcome of a probability experiment. That's P of X. I showed you P of X, so that's not important. Now, this is important. This is important. Now, whenever you're doing some of these problems, you may get confused, okay? Because they're going to use 2 slogans. And those 2 slogans, it helps if you have a number line, present. Now, I've seen a lot of teachers teach, conferences and stuff, and they talk about this, you know, you go into a Math 120 session and they talk about this and they say, I even, you know, the teacher teaching, I even write down a number line, okay? The teacher's teaching at a conference and she's got several degrees and she's using a number line. I teach and I use a number line and I got several degrees. How many degrees do y'all have? So what should y'all be doing? Using a number line, okay? Although we still have people that think they invented, you know, at most and at least. At most and at least. You also will be using what we call the complement here. And somebody that had the book, I can't ever remember because there's two ways to write complement where they mean different things. And I think in the book, I think it's with an E, but I'm not sure. Somebody correct me if you have a book. Okay, complement. 1 minus the probability of an event. Okay? So at most, let's say at most 1. No, at most 3. If I say at most 3, what does that mean? That means that your highest number is what? 3. So write that down up under. Highest number is 3. So that means 0, 1, 2, 3, and you're going to add those probabilities up. Now the complement, I'm going to do that in red. I don't like to use red, but usually what's the opposite of black? Red, because you can't see white on a whiteboard. So, what would be the complement of 0, 1, 2, 3, 4? Somebody tell me. 1 minus the probability of what? I didn't hear you. I can either take the probability of 0. That's not right. I should have wrote that down in black. Hold on a second. There we go. Let me go with black. Either I can do the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. Or I can do what? 1 minus the probability of what? 4. Remember, what is all probabilities equal to? 1. So I can either do the probability at most 3. I can do probability of 0 plus probability of 1 plus probability of 2 plus probability of 3. Or I can take the easy way out and just do the probability of 4 and subtract it from 1. Okay, if you look at the number line, you see what I'm talking about. Let me take this highlighter, and I'm going to highlight. I don't have a highlighter on this. I don't understand why on this I don't have a highlighter. Okay, so I'm going to take a green pen, and I'm going to highlight this. There. Now, what's left? What's left out of that? The only thing that's left is that 4 out there. See that 4 out there? Well, I can take the probability of 4 and subtract it from what? 1. That 4 is out there by itself. All of these probabilities together is equal to 1. You'll see that here in just a minute. Okay? So I can use the probability, the complement, and take the probability of 4 and away from 1, and it will equal that. Question. You'll see it as we go along. All right, now let me do something else. Let me do at least. What does at least mean? That means your lowest number is, so let's do at least 2. So what does that mean? That means your lowest number is 2. So that means this one, and this one. Because your lowest number is 2. Everybody with me? So I can do the probability of 2 plus the probability of 3 plus the probability of 4, or I can do what? One minus the probability of 0 plus the probability of what? 1. Now that one, you're going to have to work both ways. Do you see what I'm saying? Sometimes the complement can be real easy. It'd be just one number. Sometimes it might be 2 numbers versus 3. Do you see what I'm saying? You can find the answer of at most and at least 2 different ways. You see that? I hope you can. You will probably eventually. Okay? We're going to move on because you're going to see it later. That's a discrete random variable. When you either got, let me give you an example of what a discrete random variable is. A household. What do you mean a household? Can you have 1.5 households? No. Can they have 1.5 boys? No. You can only have one household. So it's either 1 or 2 or 0 or 5 or 6 or whatever. You can't have 3.5. What is the probability of 3.5 households watching this TV show? You can't have that. That's why it's called what? Discrete. What does discrete mean? You count or measure? You count. And you can't count 3.5 households. What does continuous mean? You measure. So write that down. Continuous means that you're going to have fractions, decimals, and percents in there. And you'll see that later. I did send my boss an email that says, does this mean that I will have to do posters at home? I had to get that in.
Did you really send that?
Yeah, I didn't get a reply back.
Oh.
I'll get a text back, say smart ass or something like that. Oh my goodness. The bread shelves are already emptying in South Carolina. Oh Lord, we're stupid. Yep, the coronavirus is going to come into South Carolina like the angel of death came into Egypt. And you're going to have to put blood on your post and lintel, lamb's blood. Okay, get through probability. There we go. A probability distribution of blah, 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 blah. There is a probability distribution. Go ahead and write it down because that's a good example. Notice, is there any negatives or any numbers above 1 on the right-hand side? No. And if you add those up, what do you get? Take a calculator and add them up. You should get 1. And they're going to show you a couple of examples after this that do not qualify as probability distributions. In 2004, there was SARS. In 2008, there was avian flu. In 2010, there was swine flu. In 2012, there was MERS. In 2014, there was Ebola. In 2016, there was Zika. In 2018, there was Ebola. And now in 2020, it's Corona. Check it out. What? Yeah, we are going to die. I'll tell you that right now. I'm 100% sure we're going to die. And now when we're going to die, I don't know, but. All right. So the event is on the left. 0, 1, 2, 3, 4, 5. You say games of the World Series. Or you could say, you know, whatever the event is, you're going to see some examples of that. And you see, and if you add all these up, let's see, 58, dang old 80 cent, 90 cent, 96 cent, 99 cent, $1. This is a probability distribution. Now they're going to give you an example of what is not a probability. There's the two tests. I already told you that. Each probability has to be between what? 0 and 1. That means not a negative and not above 1. And all of them added up has to equal 1. This is not a probability distribution because if you add those up, you get 0.97. Now, these examples right here are all test questions, and I do put them on my test because I know they put them on standardized tests. And they'll say, is this a probability distribution? And most students just look at it and go, I don't know. And that's why, because you don't know the test. You got to have all of them equal to 1, and they've got to be between 0 and 1. So this one is not, because if you add all these up, you get 0.97. So what do you say? This is not a probability distribution. And you go on to the next problem. There's nothing you can do. This one is not because why? It's got a negative. Now there's also one on the standardized test that has 2.18 or 2.5. That's not a probability distribution. This is, and this is an example I think of the one before, I don't know. This is because your total is equal to 1 and all of them are between 0 and 1. So make sure you know those 4, examples. This is I don't know why you would, I guess to impress somebody maybe, but I don't know why you'd graph a probability distribution, but there you go. And remember, that's a histogram. I don't know why you can't use a bar chart, but. All right, the mean. Write this down. This is your first testable calculation, your mean. Read the definition. Read the equation. It says the mean of a probability distribution is the summation of the event times the what? Probability of the event. That's it. The mean is the event times the probability of the event. Now, I don't agree with the way they show you how to do this. So what I'm going to do is I'm going to pull up a handy dandy spreadsheet. And I'm just going to make event 0, 1, 2, 3, 4, 5. There's my events. Let me just go ahead and insert and call this X. And the probability of probability of X is 0.1, 0.2, 0.3, let's see, that's point what? 0.6, 0.2, 0.15, 0.05. I think that's 1. Let's check it. And check all those and hit enter. Yes. Okay, so let me blow this up a little bit. And I can't stand for things to be, there we go. All right, so now I need to do X times what? X times P of X. And that's going to be equal to this guy times, well, I can't find anything, so it's already, that coronavirus already getting me. Pull it down and copy this over. So there is my mean. Mean is equal to 2.25. So what does that mean? That means that your mean is 2.25 games. So that means that in between 2 and 3 is going to be most of your probability. So you can write that down. Between 2 and 3 events, that's where most of your probability is going to fall. Now, of course, if we're going to find the mean, then what else do we need to find? What's the two most important numbers in statistics? The mean and the what? Nope. Nope. Keep going. Standard deviation. The mean and the standard deviation. I appreciate you trying. You're a failure. All right. Mean and the standard deviation. You can go ahead and drop if you want to. You know, just drop. It's real easy to do. You can go to the computer.
Die anyways.
Yeah, that's right. You're going to die. You might as well just go ahead and drop. This is the way they show you how to do it. Okay? And I don't like to show it this way because people get confused. I do it on the spreadsheet because it's easier to see, but that's up to you. All right, so we're going to move on because I need to show you another formula. And where is that formula? Let me get to the mean. Come on, where's the... There she is. And we are going to circle this one. That's the one I'm going to use. Okay? So I need you to write it down. The standard deviation for a probability distribution is the summation of the event squared times the probability and then minus the mean squared. Now, I'm going to be honest with you. I don't know how much y'all have had, but let me ask you this. Have y'all ever seen this formula before?
No. Yes.
Okay. So there are a couple of teachers out there that are teaching it pretty frivolous, whatever. Yes, they get into it. I don't even know what the word is, but anyway. Well, I commend those teachers that are teaching this because, like I say, the more you know in high school, the better off you are in college. Okay? So that's a good thing that there are teachers out there that go into that. So let's do it. We've got to get x squared times p of x. Now remember, what are you supposed to do if you get confused? Read the what? Formula. Read the formula. All right, so I got to get x squared. So let's go back and let's just rewrite this guy on the spreadsheet. How about that? Discard. Let's x squared times p of x. Hold on a second. There we go. The summation of x squared times p of x squared times p of x minus mu squared. So I've got to have a column called x what? Squared. So I'm going to go over here and I'm going to skip a line because I don't want you to get confused. So I'm going to go over here and I'm going to put x squared right here. X squared. And I'm going to say equals, I'll do the first one for you. 0 raised to the second power is 0. There you go. I'll even do the second. I'll do all of them for you. How about that? There you go. Now all of you should be able to knock that out with no problem. So what I need to do next with the formula? I just got my x squared. What I need to do now? Time the event. So here I'm going to call it x squared times what? P of x. Excuse me. X squared, that was coronavirus, times P of x. Everybody with me? So you do it. I want you to do it in your notes so you'll have it because you're going to forget. So make sure you get the same numbers I do. I'm going to take my handy dandy highlighter and I'm going to highlight that yellow. And then that's going to be the things I do for y'all. And that's going to be that. And then I'm going to color this blue. And that's going to be, this outdated software is about to get on my nerves. It's a conspiracy. There's the blue. Now what am I going to do with x squared times p of x? I'm going to take the what? I'm going to add it all what? So I'm going to take my pink, and that's that. And then I'm going to take my handy dandy spreadsheet, and I'm going to make this pink. Just look at the stuff I do for y'all. Just go and find colors and I would be a good poster maker, wouldn't I? No. And some, and there you go. 6.85 is right here. So I'm going to take my handy dandy whiteboard and I'm going to say, okay, square root of 6.85 minus, what's mu? 2.25, so you were actually listening. Okay, now do that, and I'll do it in the handy-dandy spreadsheet. Now, if I wanted the variance, I wouldn't take the square root, remember? So sometimes you may be asked for the variance, you just don't take the square root. You just say 6.85 minus 2.25 squared. So I'm going to go down here. And I'm just going to do it in one calculation. You can do it in your computer. I'm going to do the variance just so you see, y'all know the relationship between the variance and the standard deviation. So I'm just going to do the variance is equal to this number minus this number raised to the what? Second power. That's the variance. And then the standard deviation is equal to that number raised to the what? 1/2 power, Hubert. That's right, class. There you go. And you need to be able to do that for your test. So I'll highlight that in verde. And that means that you need to be able to do that. Capiche? Now, write down those two formulas. Okay, the first formula is the mean or mu is equal to the summation of x times p of x. That's how we got that right here. And you should be able to do that with your calculator. Now, think you can. Let's pull up your handy dandy calculator, because I want to be able to show you all the technology, not just one. So I'm going to pull up the handy dandy calculator. I wasn't going to do this, but there we go. I think, pull up my handy dandy Excel spreadsheet, pull this over. Go to Stat, Edit, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. You got the coronavirus too, haven't you?
Yes, sir, it got me.
I figured.
I won't be back.
Angel of death. The angel of death is here. And 0.1, 0.2, 0.3, 0.2, 0.15, and 0.5, 0.05. No, yeah. I can't remember. Hold on. I think you can hit Stat, first variable, calculate, first variable statistic. No, might be second variable. Hold on a second. Let me play with it a second. Stat, calculate, second variable statistic, and calculate. There you go. And you feel good about yourself. But it says that the mean is 2.5. I got 2.25. I'll have to, let me verify that. See, the standard deviation is, no, it's off. I'll have to check on that. I think there's a way you can do it, but I'm not sure. We can pull it up right quick. TI 84. Yeah, this is a trick you can do, y'all. Go to Google and pull up something you don't know. It's real neat in school. TI 84 probability. Thank you. Probability distribution. Let's see what it says. That's not what I'm looking for. I'm looking for mean. Let me put mean, probability distribution mean, and standard deviation. There it is. Well, I'm not going to watch a video, because you ever watch those videos, they just talk too damn much. Yes, today I'm going to show you how to use the TI-84. My name is Ronald, and I come from blah, 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 and I'm blah, blah, blah. I'm like, shut up. You ever seen Khan Academy? Oh, my gosh. He repeats himself like 16 times. Yeah, what we're going to do is we're going to take the standard, take the square root of the derivative. Yeah, take the square root of the derivative. Right here, we're going to take the square root of the derivative. Oh, my gosh. Anyway, I'm sorry. Calculating the standard deviation probability distribution. There it is. Now they're doing. Okay, that's not what we're doing. There's the outcome. No, they're doing something different there. I'll work on it. Let me do some research, and I'll find out how to do it on the. I know there's a way to do it. I just can't remember it right now. All right, so let's get on with the program. So let's get back to, there's how you find your standard deviation and the variance. You can find the mean. That's what I'll test you on. I want you to be able to find the mean, the variance, and the standard deviation of this guy right here. Okay? Make sure, just put this in your notebook right there and say test question. Mean, variance, standard deviation. And that's all you need to do for basically that part. Okay, so I'm going to move on. I'm going to show you this because you know how to do this. If you want to find the mean of something, you add them up and divide by what? Okay? But that's if you're given all these numbers. That's the old school. That's data driven. The difference between data driven and this is you don't know how many you got. You just got what? The probabilities. That's the difference. Doing your test scores right here in school, just think of that as test scores. That's the old mean. And this is finding the mean with probabilities. So they're showing you the difference between the two. Okay? Let me move on. Okay, this is a standardized test question, and you need to write it down, and you need to highlight it and put SAT, ACT, whatever standardized test you're going to be taking. This one is going to be on there. Okay? And it says a term life insurance policy will pay a beneficiary, and you don't have to write it word for word, a sum of money upon death. Of course, that's what life insurance is. Somebody dies, so you need to go out and get life insurance policies because we're all going to die. These policies have premiums that must be paid annually. Annually means what? Yearly. Okay? Suppose a life insurance company, there's the elevator music.
Work email. Hi there. It's currently 9:05.
And we're all going to die.
With a current
Suppose a life insurance company sells a $250,000 1-year term life insurance policy to a 49-year-old female for $530 premium. Okay? According to the national blah, 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 the probability that a female will survive is 0.99791. Why is it so high? Because males are stupid. How many stupid videos do you see on YouTube, and how many are men and how many are women? You know, like the bale of hay rolling down the hill and the guy's trying to jump over it. How many women you see do stuff like that? Not many. Okay? Or the ones that get me are the ones that jump off the roof and doing the wrestling, you know, jumping off the roof and diving into a table on top of another guy. Those are real smart. Yeah. Anyway, 0.99791. So what's the probability of a woman dying? The complement of 0.99791 is right there, 0.00209. So you have the event on the left and the probability of the event on the right. This is just like the problem we just did, only I had 5 probabilities, 5 events. This one only has 2. You either dead or you're what? Alive. Now, what if you're alive? Then that means that the insurance company gets $530 of your money. Everybody with me? What if you die? Then the insurance company loses $249,470. Why? Because they got $530 of your money, but they got to give you a check for what? Not you, because you're dead. They got to give your family or your beneficiary a check for what? $249,470. And why is it negative? Because they have to pay it out. So, the expected value, highlight expected value, because that's what this is. The expected value is the 530 times the probability of living plus the probability of dying times the negative 249,000. So the insurance company has a positive number, so that means that they are doing well. Okay? If it was negative, then that means they need to do something different, because negative in business and money is what? Not good. So make sure you write that down. We're going to stop here and make sure somebody makes a note that we stopped at expected value, because I don't want to get mixed up like I did last time. Okay, with the 110, with the 12010 and the 12023. Okay, so let me go and shut this down and go to the handy dandy Skype and shut this down.